Hello and welcome to my third video on digital image processing and analysis using Microsoft Excel. My name is Dr. Peter Akunlabi, Assistant Professor of Agricultural Systems Technology at Arkansas State University, College of Agriculture, Engineering and Technology. In this video, I will introduce you to some of the operations used in image pre-processing. Remember that the image pre-processing stage aims at correcting distorted or degraded image data to create a more reliable representation of the original scene, and also to improve the utility of an image for further manipulation. In this video, I will demonstrate how to correct or minimize random noise, also known as salt and pepper noise, in an image data. Here is the folder we'll be working on, and here are two images we would be comparing. This is the original image that we would be looking at, but this image does not have any noise. And for the demonstration, I have imposed some random noise on the image. So this represents what you could get from a sensor which has the random noise, and we would be working off on these images in a moment. Alright, so let's start by opening the RGB2X software and use that to extract the RGB data of these images into Microsoft Excel so that we can continue from there. Okay, select files. We need to work on multiple files. On the desktop, we have image processing and random noise. Let's select both images because we will be using them, and then open. Once this export button becomes active, we'll click it and then export the data, RGB data, into Microsoft Excel. Once the data is in Excel, we can go ahead and work on the data. Alright, here is the the operation is complete. We have the data extracted into Excel files. Let's start off by looking at the data, the image that has not that has no errors. Okay. All right, here is that image. Remember, we have our data from the red band, data from the green band. Here is data from the blue band, and the UC data representing one-dimensional image data from the three bands. First, let's go ahead and change these values to the R, G, and B. We'll be using this. Let's visualize our red band data to see how it looks like. Remember, the data would already be selected by the time you open the file. This should be selected. So to visualize, go to Insert, click on this button to see all charts. Then in the Insert Charts, click on All Charts, And remember, we have to use a surface chart to visualize the two-dimensional spatial image data. Okay. Let's use contour and then click OK. All right. All right, we can do some comparison over here. Look at the original data. Let's see. Okay, just as I explained in the previous video, when you visualize your image data in Excel, Excel is going to present the data, the data as flipped. The reason being that whereas your A1 represents the actual pixel location and value for in the original image, Excel would plot it, rather placing that A1 pixel data on the bottom left. So once we visualize this chart, we have to flip it upside down, and to do that we double click on the vertical axis, which is a series axis, and then that opens the right pane for your format pane. Here we have to make sure that the this icon, which is like bar charts, is selected. That is the axis options, and then we would select series in reverse order. Click on series in reverse order, and that should return your image into the right orientation. And we can compare that with the original image to see. Okay, all right. So now we have our image in the right orientation. We are looking at the red band image, and we can see it shows three different colors. We have blue, orange, and gray, and these represent different range of values. Remember all the steps that we had to go through to increase the number of or to control the number of colors, which is the number of the number of range, narrow ranges here. All right. Let's go ahead and change these colors just to visualize this. Change it, this to 5 colors. Okay, change this to 5 colors. This is red band data, and we'll try to work with data that we'll try to change the colors to represent the red band appropriately. To do this, let's change the chart type to 3D. Okay, that's to the 3D surface. Remember? All right, we select 3D surface chart here. Okay, click OK, and then the 2D becomes a 3D. Let's wait for it to load. Okay, here is our 3D visualization. We want to notice that once we came to the 3D, Excel automatically changed the number of ranges. So we have 1, 2, 3, 4, 5, 6, whereas previously in the 2D visualization, that's in the contour chart, we had only 3 colors showing. Now Here is what is happening. If you double click on the vertical axis here, which is the pixel value axis, and click on this axis options, and then expand the axis options, we have bounds and units. The bounds, we have minimum, which is a 0, the minimum value, maximum, which is a maximum value, maximum pixel value, and then you have units. Let's forget about the minor units and think about the focus attention on the major units. The range, that is the maximum minus the minimum divided by the major unit, will give you the number of colors here. Okay, so we have 300 divided by 50, and that gives you 1, 2, 3, 4, 5, 6. All right, but we know that the values, the pixel value goes from 0 to 255. So in actual fact, beyond 255 there is no pixel value. We can leave it like this up to 300, and then for us to get 5 colors, it means that we'll have to divide that by we'll have to divide this by 60. On the other hand, we can just rather than thinking setting it to 255, we can also just make it 250. So 250 here, change the 300 to 250. That's the maximum bounds to 300. And once we change that, this auto will change to reset, which means that we have touched it and we have fixed it. And Excel is not going to change it back to a different value later on when we switch back to the contour chart. So we're going to leave the minimum value to be 0. So we have 0 to maximum of 250, and then our major unit will keep it at 50. So 250 divided by 50, we will have 5 colors. I want to keep the minimum really at 0. We don't know what Excel is going to do. It says auto here, which means that if Excel wants to change it, Excel is at will to change it. We don't want that to happen, so best practice, add a 0 to this, which means you've really not done anything to it, but you just want Excel to acknowledge that you want it fixed at 0, really. So let's see, this changes to reset, and then this 0. Excel is not going to change it. Major units too, let's do the same, just add a 0 to it. It's going to return to whatever it is, but the auto will change to reset, which means that you are in control. All right, now we have 5 colors, 1, 2, 3, 4, and 5. Now we want to change the colors to better represent what we are looking for. We have a blue on this low end, we have another shade of blue on this high end, which is not a very good which is not going to give you a very good visualization of your data. We have an orange and then another sort of orange here that is not very good. So we want to change the colors appropriately to represent what we want to see. Let's change the chart type back to contour view, the contour chart, so we can see it in 2 dimensions. Now at this point, I'm just visualizing. I've not started working on the error correction, but I just want us to visualize this because we will be using it to do some comparison here. All right, so let's change the 50 0 to 50 from blue. Let's make it some shade of red. Okay, how about let's see, okay, before we do that, let's set the maximum range to be red, so it's an actual red color. and let's change this to a lighter value, a lighter say, okay, let's change this to another value of red. We really want to change it to a lighter red, not the same color. How about, okay, we can do one thing. Well, let's just select any color that is a little lighter than what we have. Go to this, okay, all right, I'm gonna have to go back and do this. Let's start with a maximum one. Go to more colors, more fill colors here. Rather than use the standard, let's go to custom and move this down and select something at this. Yeah, this color is a red 19200. Okay, 19200 for the first the maximum range, and then let's go to, let's change this one to, remember this was what, 192. 192. Now let's move that, make it lighter. All right. Okay, let's keep it here, say okay. We just want to have different shades of red. Let me write down what we have used here. We have used 192 and we have used a different color here. This was 192 for the red, and this was 246. Okay, 246. Let's see. So all I'm doing is just changing the colors. Custom 000 all, 246 just gives us back to this red range. Let's reduce this a little bit, make it 255, 255, 79 and 79. Okay, let's okay that. And let's change this to a different color. Okay, this was 255. Okay, 79. Let's go down a little bit more. 255, 125, 125, 255, 125, 125. Okay, there we go. And then the last value, let's change this to another shade of red. Make this custom. Make this let's say lighter. Okay, didn't even check what it was. Let's go back and see what was this one. Okay, that was 255, 221, 255, 221, and 221. Okay, so basically what we have done here is we have changed the colors so that they would better represent something. Because we are working with red, I chose the colors to be more of reddish, so that gives us some keeps our focus on the fact that we are working with red. Okay, now let's go to the UC data and produce a histogram of this data that we have here. We would compare this two-dimensional, which is a contour chart, with that of the noisy chart, and then we would also look at it after we have applied a correction. So we would use similar colors when we get to that point. Let's go to UC, and here we want to use this data, the R data here, to we want to obtain a histogram of this R data. Let's call it pixels, and our bin, that is going to be the range of colors we're going to use. We want to select, we want to count the number of pixels that make up the number of pixels in every pixel value. So we want to start from 0 to 1 to 2, and we're going to select all of this and drag it all, so we have 255, which is really 256 colors, including 0. So 255, this is going to be all our pixel values. So we want to count the the number of pixels that are in any of these that fall in any of these values. Okay. All right. All right. So remember, to get our histogram, we have to go to data. Click on data, and the last time we included the data, data analysis toolbox, and I don't seem to find it here. All right, you can't seem to find it here. All right, let's go through the process again and call it in. Go to File, Options, and we would see Add-ins, and we'll go to Manage Excel Add-ins. Go. Oh, probably we did not save it the last time. There is Analysis 2-pack here. Click on that one, OK it. All right, Analysis 2-pack. It comes under data, and that is Analysis 2-pack. Click on this. We don't want a random number generation, we're looking for histogram. Here is a histogram. Select histogram and click OK. Now in the histogram dialog box, we have input range. The input range for us in this particular demonstration is the R, all the R data. We can select all of these, but it's going to be thousands, several thousands. of data. So rather than select all the cells, we can click on the header here and select the entire row column. Bin range. Bin range is actually referring to the individual ranges. In our cases, we are using this individual values, not the individual ranges. So we select all of these. We could have selected the entire column. Select all of this, and then we have labels. This has R and this has pixels, so check the labels. And then now it's looking for output options. We don't want to put this on a different sheet. We want it on the same worksheet, but we need to pick a place where we would put the output. H1 would be an appropriate place to place it. And then in terms of charts, we just want to see a chart output of that histogram. Click OK, and there is our histogram. It's taking a while, but should be done soon. Okay, so once the data comes, what we would see in the histogram is that we would find the number of pixel points that have 0. Okay, so here is a histogram. Let's close this format pane so that we can see it well. So these are just counts, frequency. So in 0 we have 75 cells have a value of 0 and so forth. So this is the distribution. This is what the data, the image data that has no errors. This is what it shows. Now let's delete this. And let's go to look at the other data, the data for the image data with the noise. And then again, before we see that, here is it. Here is the data with the image for which we were working on, and here is the data where the image with the noise imposed on it. We want to compare between the correct data and the noisy data, or the clean data and the noisy data. All right, let's okay, here's the image data with the noise. Let's go back here and save our work. So okay, open this one. All right, and probably okay, we have the red band data here, and I'm going to run through this a bit quickly because we are taking our time to look at creating the charts. We want to look at a 2D chart. Maybe it would be a better idea to go straight to the 3D, since we will have to make some adjustments. So let's select that one, and then there we go. All right, double click on the vertical axis, which is the pixel value, the pixel axis. All right, and then we have the minimum value to be 0 and maximum to be 250, consistent with what we have set. But we have auto here. We want to keep that preset. We want to tell Excel that we want it to be fixed in those locations. We want the values to be fixed to whatever we want it to be. All right. Okay. Now that we have done this, we can go back and look at the change the chart type to contour. Here we go. Okay, here's our contour chart, and remember we have not flipped the image, so we have to double click this or click on the vertical axis in the contour chart, and then make sure that the axis options is selected, and let's check series in reverse order. Series in reverse order is going to return the image into the correct orientation. Well, this image is really infested with noise, but we'll see what we can get from it. I have the colors that we have used for this. Let's do it quickly. Change this color to okay, we can select it. We still have it in memory. Oh, we don't have it. Okay. We used 255 here, 255, and then this was 221, 221, and this was another 221. That was the lower side. The next was 225. Two two five, 125, and then 125 again. Okay. The next was 225. Then we have 79, and then 79 again. Okay. This is just 246, 246, and then we have 192. Okay. Okay, so there is an image. You probably will not see this very well. It probably has a lot more of the 200 to 250s because of the random noise, but we would see. We cannot tell much of the difference here because of the monochrome type representation we have generated here. But the histogram is going to give us a better it's going to give us a better representation. Let's just select this value from here, this column, and take it to the, it was BF. Let's paste it in F. Insert copy cells. Okay, now we can do change this to R, G, and B. Okay, now under data we have data analysis. Select that one, select histogram, click OK, and data is already selected. Our range, input range is selected. Bin range is also selected, and then our output range, and we also have selected the chart output. Click on it, OK, and then we would have and then we would have the histogram displayed. While we wait for that, okay, I have a PowerPoint presentation here, which would use just to receive the images for comparison once we have everything ready. So in actual fact, I've not gone into the error correction yet, but I just want to show the difference between the difference between the data that the data from the clean image and then the data from the noisy image. Here is the data from the noisy image. Can we change this to, let's say, okay, before I do, let me copy from the correct data. Here is R. Let's copy it and paste it in the PowerPoint. We're going to use that for the comparison, as I said. Okay, so here we go. Come on. All right, so this is if we want to change it, let me call it clean image, so that we image and okay, clean image. Let's go and copy the other one, the histogram. Copy the histogram and let's paste that there, here. All right, here is a histogram from the clean image as well. Let's pull this in a little bit. All right, so this is also from okay, so histogram from the clean data, so clean image, and this is coming from the red band. Remember, it's coming from the red band. Okay, Now let's go and copy the other one. This is paste this here in the PowerPoint. Okay. Okay, there we go. Okay, let's what do we have here? I think a little more drag and then we can compare. Just a little more. Okay, now let's look at the let's copy the histogram. Copy and then paste it here. Arrange. Uh-oh. Okay. Oh, come on. All right, we'll leave it here and just look at it in slideshow so that we can see, we can better compare. So we can see how these two different representation show. On the left side you have a clean image. C, you have the clean image. And that shows better distinction between different sections of the image. The right side image is showing the noisy. You can see that there is a lot of grain. It looks very grainy in the noisy image, and you can see how the data is really affected by comparing the histogram. You can see the distinct peaks showing in the clean image. In the noisy image, you can see how everything has been smoothened out. So there is a distortion of the information that we really can get from the clean image. So we want to see how we can reduce that distortion, assuming we had image like the noisy image, and that's all we have in a moment, and we need to process it further. We first have to pre-process it by reducing or correcting the noise in this image data before we can use it in further analysis. And that's what we will be doing in a moment. Since I'm stretching the let's see. Okay, let's close some windows here so that we can have memory to do what we need to do. Okay, now let's close this one, delete that. We have only, come on, we have red, green and blue. Now for us to apply any correction to, or even manipulate data in manipulate the data, the original RGB data, we need to create a new worksheet and apply the what do you call, the equations or the formulas, making use of the original data. So we can't work directly with the original data. We have to create another worksheet and then insert appropriate formulas that will make use of the original red, green and blue data, depending on what we want to do. Because we have already created a chart in the red band, we want to do the corrections in the red band. Instead of creating a new worksheet and starting from scratch, what I recommend and what I do is that I create a copy of the red band data, or the copy of the whichever data I'm going to work with, and then I make the correction, the appropriate corrections. Let's go ahead and create a copy, and then we can use that. So right click on the worksheet tab, and then go to move or copy. Move or copy. We don't want to just move it. We want to create a copy and then use that in going forward. So let's move it to the end and say create a copy. So it's going to keep the original copy, and then create a copy of that. Let's see. So here is that one. Double click it to change the name, and we want to make it, let's see, corrected. Okay, or correct R. Let's just say correct R, where we're going to apply a correction. Or rather than say correct R, let's change it to 3 by 3, which is the approach we are going to use to correct it. Okay. Now, I would explain the 3 by 3, how it works. Maybe I can exit here, the slideshow, and I'm going to demonstrate to you how to apply the 3 by 3 window filter to correct the noise image. And just to place a stress on it, we can correct the noisy image. However, we may not necessarily be able to restore it to the original. We will not be able to correct it to the extent that we have a fully, we have data that looks like exactly like data that did not have any noise at all. So in our effort, what we would tend to work at is to improve the data, and you might not even get meet the situations where you have to do this, but just that we want to be able to know how to do it, so that when you you find yourself in that situation, you have to do any correction, like for this random noise, you can actually do so. Since we are playing with, okay, come on on. All right, rather than explain everything, I will go ahead and just apply it here. So because we have copied the R to this and made it 3x3, means that the data is exactly the same. Now we just wanted to use this as a cell and work on it. With a 3x3, really what we have to do, let's create a copy of this here, and then let's do this. All right. Let's say you have data, okay, and then in your data, let's just have something like this. Say this is a section of your data, okay. You have cells and cells. Pardon me, just using this as a representation, okay. So assume each cell to be a pixel. So that would be, let's say the cell in the Excel. All right. Let's say this is all we have, and let's say we have 61 here, and say 31 here, and we have 255 here, and say we have 200, and then others, say 43, and then let's say 81, and 95, and say we have 88, and then we have 180. This is just arbitrary values that I'm using to explain the 3x3 window filter. 61 here, and say we have 300, and then we have 85, and then we have 62, and then we have 15, and then this would be whatever it is, okay. So let's say that let's choose a different color, maybe blue. So let's say we want to apply the 3x3 window to, let's say, 95, or let's say to 1. Okay, so 1 is a very low point, and we know that this data has random noise, which is a salt and pepper noise. So what we do here in the 3x3 window, we consider a square around that data, and and the square is pretty much based on, we have 81, 95, 88. That is 3 columns and then 3 rows. So the 3 by 3 is basically 3 rows by 3 columns, or 3 columns by 3 rows, and that window is around the point of interest, the pixel that you want to correct. So what we are going to gain, we are going to do here, is that instead of using the 1 as a value, we will obtain an average of all the, so we have, let's say, 81 plus 95 plus 88 plus 180 plus 78 plus 1 plus 61 plus 300 plus 85 plus 62, then plus 15, and that is going to be 3 by 3, 9. So this divided by 9 means divided by 9 means that we have the average value of all these. So in a new worksheet, the value that is going to go into this cell, this corresponding cell, is going to be the average value of all the cells that fall within that 3 by 3. Now we cannot selectively do this for individual points, so what we do is we apply this 3 by 3 window to the entire image, so that the correction is done across board, regardless of whether the pixel was in error or not. But to apply it across board, we stumble across this challenge where, for instance, 61, which is the A1 location, you ask, how can we correct this one? Because we can't have a 3 by 3 around that, because that is at the corner. And then all the values, all the pixel values in the first row, in the first column, or in the first row, we can't have a 3 by 3 around it. So what we do, or what we can do, is to leave the first row, the first column, the last row, and the last column alone. So keep those in the same value. So those will be the same value, and then any other thing that is within becomes the what do you call it, corrected. Okay, so we apply the correction to the inner cells, but not to the outer rows and the outer columns. Okay, I think this should provide a good overview of what a 3 by 3 window entails. I'll step over from here, from the presentation. Let me keep this annotation here, and then move on to back to the Excel. All right, so we would do it. We would keep all this first row, the first column, first row, the last column, and the last row intact. We'll keep them the way they are. But to better express this, rather than leave them in the same unit, we would rather say A1 is equal to, click on R, A1 is equal to A1, that is A1 in the the new data set is equal to R, A1 in the R. So that's the value. Okay. So that is R, A1. We can select all this. I mean, click on this corner and drag it all over. That's a lot of data. So what we can do to do that is to select the this cell that we have now entered the formula, copy it, step down a little bit, keep shift on your keyboard, the shift key and the control key together, down, and then press the bottom arrow, and that will select everything, and then enter. Okay, so that formula is copied. In the same way, we can do this to the first row, copy, keep control and shift down, the right arrow, and then enter to apply that. Now let's select the last cell on the first row, keep control down, and then just the right arrow. Look at the formula. It's corresponding to the R data. Again, Control C would copy. This is copied. Step down with a down arrow, keep shift and control down, and then down arrow to select everything. Enter to copy the formula. So everything has it. Now we are left with the last row. Okay, we are left with the last row. All right, the first cell in the last row has the formula. Control C to copy, step to the right, keep shift and control down, and then right arrow, and then enter. Okay, so now we have assigned the edge cells, that is the first and last column, first and last row. We have assigned them to the original data. Now let's move inside. Now B2 is inner. We can have this selection, which is a 3 by 3, 1 2 3 1 2 3. We can select that from the R to correct the B. So let's do that. This is equal to, now we would enter. We can enter it directly here, but I usually prefer, once in a while I prefer to come to the formula by with this cell selected, to click in the formula field and type it directly in there. So this would be is equal to average. Select average. Okay, what are the numbers? What are the numbers to fill the average formula? Go to R for red, select A1 all the way to C3, and that is a 3 by 3. It's a 3 by 3 around the B2 location. Enter it, and you can see here is that. Okay, now that is corrected. This is the average. This is an average. See, let's check this. This is the actual assigned to the actual value, this is assigned to the value, this is assigned to the value, this is assigned, but this is the average. So we're going to do this, we are going to copy this average formula, that is implementing the 3x3 correction, 3x3 window correction. We'll copy this, keep shift control down, right arrow, it goes all the way to the last column. But remember that in the last column we want to keep it the same values as original R data. So after that selection, keep shift down, only shift, and then a step back, right, left arrow. Okay, and then same way, keep control shift and control down. Now step down, that's a bottom arrow, down arrow, and that will select the up to the last row, but we don't want to select the last row, so keep shift alone down and the up arrow. Now we have just the inner cells selected. Okay, just the inner cells selected. Okay, can you see that? Now we can enter and apply the correction. Okay, looks like we achieved something. We have applied some correction here. It's probably not going to be the exact, but we have applied the corrections. Okay, all right. Now I think I don't know how I'm going to get this data back into, to one-dimensional, just as we have for the original one, but at least I can go and paste that in PowerPoint, so that we can see the change or the improvement. Okay, so it's not exactly what the original clean data looks like, but it's close, or it's a better form, it's improved. Okay, so come on, all right, there we go. So we have a clean image, we have the noisy image, and we have the corrected image. Let's make this corrected. All right, corrected data. Let's see, corrected data. Okay, now this is how it looks like. Again, we applied a whole lot of random noise to this image, and we see that we have been able to correct it a bit. The left one again is the clean data, the clean image without correction, without noise. We apply the noise, and we can see that in the middle image, and we can compare the histograms of the original clean image and the histogram of the noisy image. And beyond that, we can look at let's look at the corrected image and compare. The corrected image shows and gives us a better visualization of the data than the uncorrected erroneous one that is in the middle. However, there is some smoothing in the data, and again, this is a better or improved form, but it does not restore it. It does not represent the ultimate best shot. So I hope this demonstration is clear as much as possible, and you can follow the steps involved in applying the 3x3 window. Actually, is straightforward, as you can see. Yeah, we only had to keep the edge cells the same, and then apply the 3x3 window to the inner cells. So that concludes this demonstration. You probably wouldn't need to go through the first steps where we were comparing, because that was just to to demonstrate and compare. But if you want to apply the correction, you just have your uncorrected data, and then create an additional worksheet, or you can create a copy of the data for which you are trying to do the correction, and then by doing so you have your data already in place. The cells already populated, so that you know exactly which cells have data, and then you can properly apply the correction. So thank you very much for watching this, and in moving forward I would be moving on to talk about image enhancement and so forth. Thank you.